All right. So let's go over this problem. So FRAPPY stands for free response AP problem. Yay. They're the biggest component of your AP exam. And last year it was the only component of the AP exam because there was no multiple choice. We still don't know what's going on with the AP exam this year, if it's going to be multiple choice, if you're going to have to be sitting in a classroom taking it. None of that's been confirmed. My feeling is it's going to be online. Most by May, my feeling is that they might try to do something where you have to come into a testing type center, or even somewhere inside the school building in order to take this exam, socially distanced. But I don't know. It could change. I really don't know yet. So we're going to prepare as best we can for the material. So in this problem, windmills generate electricity by transferring energy from wind to turbine. This is background information. Study was conducted to examine the relationship between wind velocity, which is quantitative in miles per hour, and electricity production in amperes, which is quantitative for one particular velocity, windmill. Therefore, it's bivariate data. For the windmill, measurements were taken on 25 randomly selected days, so the sample size is 25. That isn't going to play a part in our question today, but it will happen. It could potentially for later on. And the computer output for the regression analysis, so it even tells us it's regression, for predicting electricity, which means electricity is my y variable, based on wind velocity, so it means my x is wind velocity, is given below. The regression model assumptions were checked and determined to be reasonable. In other words, what do they mean by that sentence right there? Can anybody tell me what this means right here? What are they telling me that you don't have to do in this problem that you had to do in the example that we did yesterday, for example?
They already checked that there weren't any patterns.
And you got to be more specific. Specific.
Yeah.
You're right, but you're no credit.
In the linear model.
Close, close. Can anybody build on what Ann just said? Look at the notes from yesterday. She is correct.
There's equal variance.
She's correct, but she's just not stating something. Remember that specificity? Can anybody chime in? You can look at yesterday's notes. She's right, but she is missing that one little piece.
On the residual plot?
On the residual plot, yes. So basically what they're saying is that, hey, we checked the residual plot and there was no pattern. Okay. And we looked at the scatter plot and it looked good enough, straight enough. So the scatter plot looked straight enough. The residuals had no pattern and basically had equal variance. So, but with that, I mean, that's just some extra information right there. The data was collected from 10 miles per hour to 40 miles per hour. Now, that also has something important. I'm going to come back to that one later on in the course when we do review. The idea that, but here's a simple, preview or explanation. Our data was only collected from 10 miles per hour to 40 miles per hour. What that means is that we can only utilize our model for x values between 10 and 40. All right, because our x values collected only occurred between 10 and 40, we can only utilize it to predict values between 10 and 40. Anything outside that is what we refer to as extrapolation, and means that we don't trust it. We do not trust any value. So if, for example, there was a 50 mile per hour wind, we couldn't use our model. We would not trust the results of our model because that's outside what we collected. It could happen that after you go after 40 miles per hour, the whole world just changes in terms of the physics, and all things go crazy. So we don't really know what happens there. So use the computer output to determine the equation of the least squares regression line. Can anybody did it? So I mean, we're gonna have to do time here. We're a little bit unstructured on time, but how does my answer look? Hopefully I hear somebody else's voice other than Anne's. Hopefully I hear somebody else's typing other than Alexandra so far. Anybody? Well, our equation tells me what the y variable is, and it says predicting electricity. So something like electricity. Explain. Thank you, Armani, for giving the response to me. Or no, that's Armani. Yeah, my internet's not too well as well. Who had typed in Z? Perfect. So going back into what I was saying, predicted electricity is equal to 0.137, which is the constant, plus 0.240 times wind. Okay, now this question typically has 3 components. Okay, so to get an E, if you have all of these stuff, everything written like this, it's an E. If you used X and Y, then you have to state the context. So if you said X and Y, you have to say what X is and what Y is. Did you state it's a model? So did you use that predicted hat symbol? That's the first thing, okay? The second thing, do you have the A and B are correct? Okay. So are the values of A and B correct? So do you have 0.137 and 0.240 in its correct placements? And finally, do you have context? Did you say electricity and wind? If you have all 3 of these, it's an E. If you have 2 of them, it's a P. And if you only have 1 of them, it's an I. So remember, that's how the exam is always graded. How much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour than on a day when it is 15 miles per hour? Now, there's 2 things you can do. You could plug in 25 and plug in 15. Did anybody figure out what you could do to this to find the answer? And this is based on a linear relationship. Anybody? How much is the change in X? How much difference do we have in here? 25 to 15. I think everybody is capable of answering this question. How far apart are those? Everybody is capable of doing this question. 10. So we're going to plug 10 into the model. Okay, so predicted electricity at 10 is equal to 0. Sorry. So you don't want to plug 10 into the model, sorry. It's just that times the slope. So if you want to find the change in y, you plug in the slope. So it's just 0.240 times 10, which is 2.4. And they tell me the units above says is in amperes. Now, I did it by plugging in, just multiplying the slope. And the reason is what you really have to do is you have to plug 25 into the model, and then you plug in 15 into the model, and you take the difference between these two. All right? Correct, with just what Ann said. If you plug in 15 and 25 into the model, what happens is that we will get 2.4. And the reason is because when you plug in these numbers, the 0.137s will cancel each other out. Okay, so basically it's saying use the slope. So it's use the slope to get the answer. So you can plug in 25 and 15 into the model, or you can get that. So this one's a very straightforward question. Did you get 2.4? And do you have the units? And did you show work? Did you show how you did that? So did you show yourself plugging in the 10 or show plugging in the 25 and 15? If you showed any demonstration of work plus the units in the answer, then that's an E. Once again, if you have two of them, if you have 1 or 0, you have two of them, 1 or 0, and if you have all three, you get an E. Okay. What proportion of the variation in electricity production is explained by its linear relationship with wind velocity? Now, this is typically, this question right here, we consider this actually an EI. That you either get it or you don't. So this is one of those ones that either you know it based on what we've learned or you don't. What proportion of the variation, also known as variability? Proportion, another word for proportion is percentage. So you could read this correct, Z, correct. It's asking for R squared. So what is it? I get a little, oh, so what's the answer? Anyone? We don't write it that way. So we know that one. So remember, our answer in Mariana, you had it. Yeah, there we go. 83.7%. Make sure to write that as a percentage. And it's right there. And I told you yesterday, if they say R squared adjusted, you never pay attention to that. That's actually something that's called a multivariable regression. We're not doing that. We'll never use that, okay, in our course. So always just ignore that. So that's an E or an I. You either got it or you didn't. I think they would have given you the answer for 0.873 here on that case, in this case, but we always want to write it as a percentage. And lastly, is there statistically convincing evidence that the production by the windmill is related? I should have mentioned it. I thought I took this question out. This is last unit. This is actually the last unit that we have to cover. We do not know how to do that one yet. The answer here, though, in case you wanted to know, is yes, because the p-value is approximately 0. That's what the answer is. You do not. We have not covered this. Sorry. This value right here is how we use this idea of evidence. We have not covered that, though. So if you couldn't do D, don't worry about it. Okay. Sorry about that last part. Let's talk about this one right here. Histogram. Okay, this one I really like because this one's been coming up on the AP exam more and more, and there's a lot of students who just don't know how to do it at all, and they struggle. So what we're going to do here is we're going to create a histogram of just the defective items. And so remember, these are the Y values, so we want to do it on there. So when I make my histogram, what should be the tallest? What is the maximum for my histogram? So what do the values go for defective values, defective items? They go from what to what?
8. Oh, for the X. 6.
To 6. It should go up to 6. Why should I go up to 6?
It's gonna be 5 to 6, and 6 has 0, so we don't have to go to 7.
Correct, because and so what Anne is referring to is that when you make your histogram, the responses for 5 will land in here. So all the 5s go into here, the 4s go into here. They always go to the right of it. So in my histogram, I'm going to have it labeled like this, 5, and this is defective items. I label this. And then I have my Y value here, how many happen. 1, 2, 3, 4, 5, 6. How many had 0? How many items had 0 defects?
Wait, shouldn't your Y go to 8?
Oh, I didn't even look at the values. I was probably going to run into an error. Yeah, you should always, let me do it like this. There you go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at you looking ahead and seeing the preparing ahead. That's what I don't do. I fly by the seat of my pants and then adjust as I need to. So 1, 2, 3, 4, 5, 6, 7. Yeah, the eight's going to be the biggest one. Yeah, you're right. So there's 0 in for 0. How many ones? How many ones? There's more. There's 2. How many twos? How many items had 2 defects? 4. And 3 defects? You can see it. 8. 4 defects? 4. And 5 defects? Oh, this is perfectly symmetrical. And so that is how we turn a scatter plot into a histogram of one of the variables. Give one fact that is obvious from the histogram that is not obvious from the scatter plot. Can anybody answer? Now that you have, maybe you couldn't do this one, but now you should be all able to do it by looking at what is one thing that we can see in the histogram? What is one thing we can describe in the histogram that we couldn't describe in the scatter plot?
That is symmetrical, I think.
Yeah, I would go a little bit step further. I would say that the defective items are unimodal, and you can say and symmetric. I think if you said only symmetric, this would give you a P, where the unimodal part is what you need to get an E. Okay, so to get an E, you would have to say the unimodal part. It's unimodal and symmetric. So if you only said symmetric, you probably would get a P. Give one fact that's obvious from the scatter plot that's not from the histogram. So we want to describe the scatter plot the number of defective items tends to blank as the days went on. What is that word that I'm looking for? What do the items tend to do? The defective items. Last question before I release you. What do the items tend to do? Last question, last thing. Oh, that's not an increase. Look at the scatter plot. Look at that line I drew. They tend to decrease. So there's a negative you could also say that there's a negative relationship between the number of defects and the number of days. It's a model. It's not an always statement. So make sure you didn't do something like always. If you said it does, no matter what, then that's a rate decrease. Sorry for going over by a minute. That's what I have for you. I hope this clarifies some of the questions that you had on these topics. The wordings can be a little bit tricky. Like you're right, they're not always the same type of wording. So I hope this gave you just a different perspective on the wording. Work on your Khan Academy tonight. I'm not going to post the exam until tomorrow because I want you to work on the Khan Academy tonight. Take care, everybody. Come to office hours if you have any questions. Bye.